Okay, hey everyone. So for our Datathon this weekend, we picked track two, which is the Doctors Without Borders, presented by Ajay, Akshay, and Krish. Okay, so essentially our prompt for this track was that the Doctors Without Borders needed assistance with placement and movement of humanitarian workers. Some zones are more dangerous than others, so our task was essentially to develop a data-driven plan using data that was given to us by the Armed Conflict Location and Event Dataset, and we need to use this to identify and predict potential conflict zones. And our solution for this essentially has two steps to it. The first part kind of involves creating an ML model to use past data to predict the risk score of an area, and then also use this to predict the risk of certain zones in the future so that humanitarian workers can be placed accordingly. And then also, along with this, we visualize this using a web dashboard that highlights potential hotspots for violent activity.
All right, so the first important step is to first acquire the data. So we did that using ACLED's API. As you can see, here's a small snippet on how we access the data, in this case for the United States, from January 2014 to January 2024. Here we did some ED exploratory data analysis. So we know we have to have a machine learning model. So with that, there's a lot of features in the ACLED dataset. So we did a lot of data analysis to figure out what features would be most useful for our model. So for example, we found that the fatalities metric, while it could have been useful in theory, we found that it was highly skewed towards zero because either there was no information on the fatalities for this event or there were no deaths. So we found that using fatalities as a metric for our machine learning model would actually skew our data. So in the end, we settled with latitude, longitude, year, event type, and sub-event type for our features for our machine learning model.
Yeah, so for data preparation, as you know, our dataset contains both categorical and quantitative variables. So for features, for example, like some of the categorical features are the event and sub-event types. And so for that, we create one-hot encodings. And for the sub-event types, we quantify it to a risk score from 1 to 10. And our training objective is essentially to be able to predict that risk score from past data. Another issue that we had with our data was that our labels were very imbalanced. So for example, when we quantified each event from 1 to 10, we had much more frequencies of having a rating of 1 versus like something like 7 or 10, as you can see on the image in the bottom right. And so the way we got rid of that bias is we use SMOTE to generate synthetic samples that create like balance among all these labels. So we have the same number of samples from each rating from 1 to 10, which helps reduce bias within our model. So with figuring out the right model, we went over like 3 different things. Our first model that we attempted was just a simple feed-forward neural network. Essentially, we just took the input features, passed it through a neural network, and tried to predict the risk score. And this wasn't very good. Like we didn't get very good accuracies. And part of this was because we were able to use the past events to predict the next one. And so we pivoted towards using a k-nearest neighbors model instead, right? And the good part about this was that we were able to use like samples natural data set to predict what event happens next. But the issue with that was that because k and n depends on like our training data set, if our input wasn't in the training data set, we'd get a very like weird rating. So that was one downside that we had with it. So the final model that we converged on was an LSTM. And the good part about this is that they can both use past events and time series data to predict the next one, and also isn't completely dependent on the training data. So as you can see on the right, it's an example of how an LSTM would kind of look. So we basically pass in within one city, we pass in the events from the past, like let's say 3 years, or the 3 most frequent events that happened. And with this information, we're able to predict the next future event that would happen. And so here's some of the code that we have with our model. So the left, you can see is our feed-forward model, which we just used linear layers and ReLU. And then in the middle, you can see our KNN model. It's a pretty simple model, but it's very dependent on our training data set. And the top right, you can see how our LSTM's code works. We have 3 LSTM blocks, and we have a hidden layer size. And we have a sequence length, which is the amount of past events we looked at, which in this case was 3.
Essentially, what we did was we found a data set of the latitude and longitudes of like major cities in the world and used that kind of to test our model on and to test how dangerous or how safe those areas are. And then, yeah, so we predicted risk scores of the cities on a scale of 1 to 10 in our data set to determine safety for workers. This picture on the right is essentially something that we created. So through creating an HTML website, it would show this map, which has a heat map, and then it also has danger markings, because that's kind of like the more important part of this, to show what areas are dangerous and what areas humanitarian workers should avoid. So obviously, as seen here, a lot of that's concentrated in Mexico.
All right, so how we coded this estimate map was we used a Folium library in Python. So here are some snippets on how we achieve this. So on the left, we have a Flask server that we run locally, so we can host the HTML file on our local website, on our local machine. And here on the right side, there's it's a snippet of code which shows how we use Folium to basically plot markers based on how risky the area is. So for our early warning system, as Akshay mentioned earlier, we use an LSTM model because it's really good at predicting based on past data. So for example, if we wanted to use this in the real world, we pass in the past 5 months of data for a certain city, like let's say Mexico City. We pass the 5 months of data into which we receive from the ACLED API. And then this like recency helps keep the prediction relevant to current outcomes. And this data can be used to forecast a few months or years ahead. So that can help make real-time decisions on where we should deploy these workers. So here's a demo of year-based predictions. As you can see, as the years go on, there's a different change in caution and risk areas. This is based from the outputs of 1 year's worth of previous data for our LSTM model. So as you can see, there's a slight fluctuation in where the cautious and dangerous areas are throughout the course of 2 years. All right, so here's a live demonstration of what's going on with our product. Right now, we've loaded data for just North America, just to give a quick example. As you can see, there's heat maps of different crime hotspots. You can see New York is quite orange. You can zoom in and look at smaller areas of what cities and what crime is happening on. And what the real important part is these risk markers here. These notify areas where workers should potentially think about avoiding. As you can see, places like this place have a score of 6, and score like here is 8. So this kind of helps inform what workers should, where they should be, and this can be applied to the whole world.